Hello and welcome to Crazy Math Production. Today we're going to look at a very specific homework that we've looked at. This is going to be the 6-4 Part C. It's just a little bit of help with a few of the homework questions, so this is more relevant to students in my class. So extra practice 6-4. This is the 6-4 Part C homework. I'm just going to do a few problems representative of this homework assignment. We've got absolute value of x plus 2 is less than 5. So we're going to solve the inequality, then sketch this graph. Now remember, if the alligator eats the door, then the statement is an or. So that's very important to what we're doing right here. So alligator eats the door, then the statement is an or. So granted, if it's not eating the little door, so you can think of the door as this right here, so little door. This is the alligator. If the alligator eating the door, then the statement is an or. So just a little dumb way to remember that. So if the alligator is not eating the door, there's going to be an and statement. So like we looked in one of the previous Crazy Math Productions videos, we have the normal scenario, x plus 2 is less than 5, and remember Alice looks through the looking glass and she sees this dark, mysterious, negative world. Also, we can flip this sign because we divided by a negative. Now, anytime we have an and statement, we have to combine them together. I like to think of it as an and which, putting those two together. So I'm going to flip this around and put the negative 5 on the left. And now I can move this over here so that we have x plus 2 is less than 5. And you sort of like to think of it as a little choo-choo train. It's all going the same direction here with these inequality symbols. Okay, so now that we have this together, again, if it's an or, we're not going to combine them into one statement. But if it's an and, we can make this and which. Subtract 2 from all three parts. We have negative 7 is less than x is less than 3. And so now we go ahead and sketch the inequality. And we're ready to roll. And statements. Remember Conan the Barbarian. Conan has his mighty spear. So it goes between the 2 points. Remember, if it were an or statement, we've got the little rowboat, and the oars go away from the boat. So they're going to end up looking, of course, depending on whether that's less than or equal to, the oars will go away from the boat. So these statements, depending on, again, whether it's an open or closed dot, and goes between, and or goes away from. Okay, let's try another problem. All right, let's try number 7. Okay, alligator's eating the door, so this is an or statement. So we have the normal scenario. And once you split it into the two scenarios, you drop the inequality symbols. Excuse me, you drop the absolute value sign. So no more of these absolute value signs. So 3x minus 6 is greater than 3, no absolute value signs. Or 3x minus 3, and we have the dark, mysterious world, negative 3. We have to switch the inequality symbol. So now we're going to solve each part separately. Remember, an and statement, we're going to work it all together. And we have that and which together. There's no such thing as an or which, so we're not gonna combine these together. We're gonna work on this side. So literally, I'm gonna ignore the right-hand side for just a moment, and I'm gonna work on this part. Add 6. 3x is greater than 9. Divide by 3. X is greater than 3. And now I'll focus on the other side. We're going to add 6 to both sides. 3x is less than positive 3. Divide by 3, and x is less than 1. Now it's or, so x is greater than 3 or x is less than 1. Now we sketch the graph. Remember or, you think of a little boat with the oars. So they're going to go, since this is the young man, remember the young man is unwise and keeps his mouth open. The old man is wise and knows when to keep his mouth shut. So we're going to sketch. We have 1 and 3. We're going to have the open point because these do not make it a solution, but just to either side will possibly make it a solution. So we're going to graph our or statement. And there we go. Here's the solved part, and here's the graph. Now, in the bottom section, they actually will ask you to go backwards. So in number 13, we're being asked to take a situation like this. We have closed points and shaded in between. And now what we're going to have to do is to actually write the absolute value inequality. We're going to start off by realizing that this is an and statement. It would help if I could spell. So this is an and statement. Remember, or would be coming out the two sides like that. So this is definitely an and statement. Now we're going to go ahead and write down the initial inequality. This is the old man because he's got his mouth shut. And x is wedged between these two. So negative 3 is less than or equal to x is less than or equal to 3. Well, if we're writing backwards, we're writing absolute value to fit this graph, what we're going to do is we're going to look to see that we have the positive and negative versions of the same number. In this case, we do. So it's going to make the process much easier. We're going to simply take the positive version of the number. We're going to take, once these match, once we have positive 3, negative 3, positive 6, negative 6, positive 10, negative 10, whatever that is, once we have opposites on either side, we're going to take whatever's between these inequality symbols and put it in the absolute value. Now, we'd already said that this is an and statement, so remember the statement we'd made before. If the alligator eats the door, then the statement is an or. Well, I don't want the alligator to eat the door because this is supposed to be an and statement. So I want the alligator not to eat the door. And of course, since this is or equal to, we're going to put the or equal to here as well. And that's my absolute value inequality symbol. Let's try another one. Now, in this situation, we don't have the initial, granted this is an and statement. It would be really helpful if I could spell the word and. In this situation, we know it's an and statement, but we don't have that matching. We don't have the opposites. We'd like to have negative 2 and positive 2, or positive 6, negative 6. We don't have that. So what we're going to do is we're going to try to find the halfway point, the midpoint, and we're going to do that by finding the average. So we're going to just on the side somewhere, 6 plus negative 2 divided by 2. So we're going to add them up, divide by 2, find the mean of the two numbers. 6 plus negative 2 is 4. 4 divided by 2 is 2. So we're going to say negative 6 minus 2 is less than x minus 2 is less than 6 minus 2. We're going to take that mean and subtract that from all three of the sides here. So we have -4 is less than or equal to x minus 2 is less than or equal to 4. And so now we're going to, since we have the opposites, -4, +4, that's good. We're going to take the positive version. We're going to put the x minus 2 in the absolute values. And then we have to stop and think. We know it's going to be or equal to. That's a given. But if the alligator eats the door, remember this is the door of my little house. If the alligator eats the door, then the statement is an or. Well, I don't want an or, so I need to switch that. Alligator should not be eating the door, so it would be an and statement. And that's it. Let's try an or statement. And then let's try one where we're subtracting a negative, just to make sure that we're okay with that. All right, let's try number 18 and number 20. Okay, number 18, we have 0, we have -6, and open points shaded between. All right, so again, this is an and statement because Conan the Barbarian and his mighty spear, so you can see it kind of looks like a little spear, very bad one, but spear nonetheless. So we're going to write this down, -6, this is less than, just less than, not equal to. This is a young man, keeps his mouth open, says unwise things. So -6 is less than x is less than 0. Again, we don't have opposites. We need to have, say, -6, +6. So what we're going to do is off on the side, we're going to find the mean, the average of these two. -6 plus 0 divided by 2. So add the 2 points, divide it by 2. And -6 plus 0 is -6. We're going to divide that by 2 and get -3. Keep in mind that we have to subtract this. Even though it's a negative, we have to subtract it. So -6 minus a -3 is less than x minus a -3. It's less than 0 minus a -3. And we're going to keep change. So really we've ended up adding that 3 to all the parts. So -6 plus 3 is -3 is less than x plus 3 is less than 3. Now we have the opposites that we're looking for. So we're going to use the positive version, put the x plus 3 in absolute values. And now we have to think. We don't have the or equal to, so I'm going to leave that off. Is this an and or an or statement? Well, it's an and statement. If the alligator eats the door, then it's an or statement. I don't want that. So I need it not to eat the door. And there we go. Okay, let's finish off by doing number 20. In this case, we have an or statement. All right, so if you think about this, as long as the variable's on the left, the sign will match which side it's going to. So for example, here, x is on the left, it's going to go this way to match this sign. Or, because I know that it's like the oars of the boat that go away from the boat. So that's an or statement. X is less than -6, or x is greater than 6. So we have this or statement. Now, we also have to check to see if we have opposites. We do. That's good. If we didn't, again, we would find the average of those two, add them up, divide by 2, and subtract from all 4 parts. Now, we're going to use since we have the opposites, we can continue. We're going to put the positive version here, put the x in the absolute values, and we have to ask. We do not have that or equal to. We're going to ask, does the alligator eat the door? Well, yes, because we want it to be an or statement. So the alligator should eat the door. Absolute value of x is greater than 6. And there we have it. Thank you so much for watching Crazy Math Productions.